Welcome everybody to Algebra 2, Section 5.3, Factoring Polynomials. So some of this factoring will be review from previous sections, while some of it will be new. So let's first start off with some review. This is factoring out the greatest common factor, or often abbreviated GCF. So we have 4 examples here of this. Our first example, 12a cubed plus 10a squared. Our GCF here between 12 and 10 is 2, and our GCF between a cubed and a squared is a squared. Remember that for the variables and exponents, you always want to look for the lowest common number of exponents. So this has an exponent of 3, exponent of 2. The lower of those two numbers is 2. They both have at least 2 for the exponent of a. And then now what you're left with inside is 6a. Remember that you're really dividing here when you factor out. So an extension of last lesson in 5.2 when we were dividing. We have 12a cubed over 2a squared. 12 divided by 2 is 6. And we subtract the exponents on the a's since we're dividing the same base of a. And 3 minus 2 is this 1 that we see, or invisibly written there that we, I guess, don't see. And then 10a squared is now 5. Because if you take 10a squared and divide by 2a squared, 10 divided by 2 is 5, and a squared divided by itself is just 1, or a to the power of 0. And now this is our factored form. Let's move on to number 2 here. Our GCF of 14m to the 8th n to the 5th minus 7m squared n squared will be 7m squared n squared. So 14 and 7 have a GCF of 7. And for m and n, both variables have a lowest exponent of 2 common amongst both terms. And so then our first term becomes 2m to the 6th n to the 3rd, once again subtracting those exponents. And our second term becomes 1. You do have to write a number there. You can't just write 0 or leave it blank. That'd be incorrect. Quick reminder that in order to check your work if you like, you can always distribute this back in, which is how we know we'd have to have 7m squared n squared times a negative 1 to get that original term. Moving on to number 3 here. This time our GCF between these two terms is going to be 2p to the 6th q to the 3rd. Once again, for 18 and 28, they have a 2 in common and no bigger numbers. And then p and q, we found the lower of the two numbers for their exponents. And so now this 18p to the 8th q to the 3rd becomes 9p squared plus, and then 28p to the 6th q to the 5th becomes 14q squared. Moving on to number 4 here. Our GCF between these 3 terms now is going to be 4 for the number x and y, with exponents of 1 on each of them, because this just has an x to the first and this just has a y to the first. We had to do our lowest value for those. Now, if one of them didn't have a y, for example, then our GCF would not include y either. The first term becomes 4x squared. The second term becomes minus 3xy, and our third term becomes, I'm starting to write 16 there, but it's 8y squared. My iPad was doing some trickery there on the zooming out for a second. Now let's talk about difference of two squares. This is also review. This is where we have the format a squared minus b squared. Difference means subtraction, and I like to call this a difference of two squares. Difference of two squares, there's 2 different things, and they're both perfect squares. So for example, this could be a squared, or it could be like 25 or 16 or any perfect square. It also could be, b squared could be something as well, like another perfect square such as 16, or it could be like 16x squared, for example, where 4x times 4x is 16x squared, so something times itself. So in order to identify these, it's helpful to identify our perfect squares. So let's just write our first 14 or first 12 perfect squares. It's just kind of an arbitrary number for what I think will fit here well for most people's handwriting. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, and once again, this just keeps going forever and ever and ever. And the rule to write it out is a squared minus b squared, the difference of two squares, factors into a minus b in one parenthesis and a plus b in the other parenthesis. And which one's minus, which one's plus doesn't matter. So this one could be minus, and the second one could, or excuse me, the first one could be plus, the second one could be minus, or it could be how I had it originally, and it doesn't matter even in the slightest. But essentially it's the square root of this first term, so a, and the square root of the other term, b and b. So in this example over here, it would have been 5 minus 4x in one parenthesis and 5 plus 4x, because 5 times 5 is 25, and 4x times 4x is 16x squared. So on number 5 here, this is a difference of two squares. We are subtracting. There's two things. They're perfect squares. We should always be looking for this pattern when we have two terms. We won't always find it, but it's always good to look for. And so we'll do m minus 5 and m plus 5. Some people find it helpful to write the m and the 5 up above. That way you can remember what numbers you're using and that these are perfect squares. On to number 6 here, 9x squared minus 49y squared. So 9x squared is 3x times 3x. 49y squared is 7y times 7y. So this is 3x minus 7y in one parenthesis, and in our other parenthesis, 3x plus 7y. Number 7 here, we look at this, and 5 is not a perfect square, neither is 80. But there is a GCF here we have to remove first. So we can factor out the 5, and now we're left with r squared minus 16s squared. Now if I look at this, r times r is r squared, and 4s times 4s is 16s squared. So this factors further. And so we have r minus 4s, r plus 4s, and we just have this GCF of 5 out in front. Number 8, we'll have to do the same thing where we look for a GCF first, because we notice that 72 and 2 are not perfect squares. However, they both have a 2 in common, leaving us 36c to the fourth, which is a perfect square, minus 1, which is also a perfect square. So 6c squared times 6c squared is get 36c to the fourth, and 1 times 1 is 1. So this parentheses, the difference of two squares, factors into 6c squared minus 1 and 6c squared plus 1, and that GCF of 2 just gets written in front. Number 9, another GCF here, but this time it also involves the variables. Remember that when we multiply two variables together, that we add those exponents. Well, no number added to itself is 7, or no integer added to itself is 7, and same thing is true for 3, and 1, and 1. So we identify our GCF, always good to look for a GCF first in any problem that we're factoring on. And at 7, m, let me fix my m there, n. And it'll be left with 1, m, which I guess I don't have to write the 1 if I have the m to the 6th, minus 4n squared. And even though 6 is not a perfect square, we don't need it to be, because n to the third times n to the third is n to the 6th, because you would add the exponents when you multiply the bases. And then 2n times 2n is 4n squared. So this is now n cubed minus 2n, n cubed plus 2n, and we have 7mn out in front. Oh, I mixed this up here. This should be an m, this should be an m, and this should be an m. There we go. That's much better now. Number 10 here, lots of 10s on this problem. So I have to factor out first, and then what I'm factoring out is 10w. So I'm left with w to the fourth minus 1, which is a difference of two squares. So w squared times w squared is w to the fourth when you add the exponents, and 1 times 1 is 1. So we have w squared minus 1, w squared plus 1, and 10w. But we're actually not yet done with this problem. Some of you might be quite frustrated by that, but alas, that is the case. And the reason why is because if we were to ignore all of this and we were just given this problem originally, we'd say, oh, that's actually a difference of two squares, and we can do w and 1 and call this w minus 1, w plus 1, and we just rewrite everything that we didn't change. So the 10w didn't change, we rewrite that. The w squared plus 1 didn't change, and we rewrite that. And the order in which you write this doesn't matter, so maybe this comes first, maybe it comes last, maybe you want to put it in the middle. I don't care. At the end of the day, these are the 4 factors. 10w is a factor, as well as each set of parentheses being its own factor. Now, this cannot factor further, however, though, because it's not a difference of 2 squares. It is a sum of 2 squares. And the sum of 2 squares cannot factor. It will never actually be able to factor. Let's move to something that is not review for us, but rather new to us, and that's the sum of 2 cubes. And so this is, instead of things being squared, it's things being cubed. So such as like 125 is 5 times 5 times 5, or 5 cubed, and 27 is 3 cubed, or 3 times 3 times 3. And notice that we're adding these together. And so just like it's helpful to identify some perfect squares for differences of squares, it's helpful to identify cubes for sum of cubes. And so 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 8 cubed is 343, 9 cubed, I did 7 cubed, 8 cubed is 512, I almost skipped that one, 9 cubed is 729, and 10 cubed is 1,000, and you could keep going, but we'll stop there. Our rule for a sum of 2 cubes is a cubed plus b cubed will factor into a plus b, and the other factor or parenthesis will be a squared minus ab plus b squared, where a and b are the cube root, or whatever cubed would get us a cubed and b cubed. So let's dive into number 11, so this might make a little bit more sense to us. X cubed plus 27. This is a sum of 2 cubes, because x times x times x, or x cubed, is x cubed. And 27 is the result of 3 being cubed, or 3 times 3 times 3. And so we follow this pattern with x being our a and 3 being our b. So one parenthesis or factor is x plus 3. Other parenthesis is x squared minus x times 3, which I'll write as 3x, plus 3 squared, which is 9. If you left it as 3 squared, that would not be fully correct, because you'd have to simplify that to 9. And now this is the fully factored version. Now there is, we do have 3 terms here in that second parenthesis, and so you might wonder, do I have to factor that further? And the answer is that if you could, you would factor that further. However, you can't factor this any further, so we won't. And we won't be needing to on any of these examples, just to be clear, or any of the things that we'll be doing in this classroom, also to be clear. 8w cubed plus 1 is also a sum of 2 cubes. There's no GCF here. And 2w times 2w times 2w, or cubed, gets us 8w cubed, and 1 times 1 is 1. And so we have 2w plus 1 for a and b. And then 2w squared is actually 4w squared. And then minus 2w times 1, which is 2w, plus 1 squared, which is 1. Once again, just following this pattern. Now notice when I squared a, which was 2w, I didn't just do 2w squared, but I rather did 2w times 2w and got 4w squared. Moving on to number 13 here. M cubed plus 216, n cubed. No GCF. M times m times m is n cubed, so that'll serve as our a. And 6n cubed would be 216n cubed, so that'll serve as a b. So following our pattern or rule, we do a plus b, which is m plus 6n. And our other parenthesis is m squared, a squared, minus a times b, or m times 6n, which is 6mn, to put it alphabetically with the coefficient first. Let me write a better m there, or less bad might be a better term for it, plus b cubed, which is b squared, 6n times 6n, which would be 36n squared. Some of us may benefit from writing an in-between step for the second parenthesis where you write m being squared, you write minus m times 6n plus 6n being squared. If that would benefit you to write it out that way and then progress to the next step, feel free to go ahead and do that, of course. Number 14 here, also a sum of two cubes. No GCF. We have 7p cubed would be 343p cubed, and 4q cubed would be 64q cubed. So 7p plus 4q for a plus b. And then a squared, which is 7p squared, is 49p squared, minus a times b, or 7p times 4q, which is 28pq, plus b squared, I almost said minus, which would be 16q squared. And that would be our answer. Moving on to number 15, 500 is not a perfect cube. 4 is not a perfect cube. A cubed is, but we need to factor a GCF here. Our GCF is 4. And so we end up having 125a cubed, which is a perfect cube, and 1, which is also a perfect cube. So we have 5a and 1 as our cube roots. So 4 will just be written out in front, and then we'll follow our pattern. So we have 5a plus 1, and then 5a squared, which is 25a squared, minus a times b, which is minus 5a times 1, and then plus b squared, which is 1 squared, which is 1. And that would be our answer. Similar happenings here on the next problem where we have a GCF. 24c to the fourth d plus 375c d to the fourth. Here, our GCF this time is going to be 3cd. One way you can know there's a GCF is that neither of these terms are perfect cubes or perfect squares. So then we're left with 8c cubed plus 125d cubed. So cube roots of these are 2c and 5d, and so we'll put it in the rule accordingly, with 2c being a and 5d being b. So we have 2c plus 5d. In the next parenthesis or factor, we have 2c squared, which is 4c squared, minus a times b, or minus 2c times 5d, which is 10cd, plus b squared, which is 5d squared, which is 25d. Oh, I did not leave myself enough room on that second parenthesis. So we end up having that as our answer. Moving on to difference of cubes. This is very similar to the sum of cubes, except for now we see that it's a difference instead. And so it changes the rule ever so slightly to where now this will factor into a minus b instead of a plus b. And then in our next parenthesis, it's a squared plus ab plus b squared. So you'll notice these two signs just swapped. When we had a sum of cubes, the sign of the first parenthesis was positive, the sign of the sign before ab was negative, and now it's the exact opposite, to where the second parenthesis only has plus signs and the first parenthesis has a negative sign. In both rules, though, for sum and difference of two cubes, the sign before b squared is the exact same both times as plus. So let's practice some of these problems. So on number 17, the cube root of x cubed is x, and the cube root of 1 is 1, and so we follow the rule with x being a and 1 being b. So we have x minus 1, and then x squared for a squared, plus 1 times x, which is x, plus b squared, which is 1, and that is our factored form. Number 18 here, our cube root of each one would be 4 and w. And so we do 4 minus w. And then our other parenthesis, it's going to be 4 squared, which is 16, plus a times b, or 4 times w, which will be 4w, plus w squared, which is w squared. Number 19. The cube root of each of these, so cube root of 216k cubed is 6k, and the cube root of 125 is 5. So we'll follow our pattern. 6k minus 5 in the first parenthesis. Our other parenthesis would be 6k squared, which is 36k squared, plus 6k times 5, or 30k, plus 5 squared, which is 25. Number 20. Cube roots for each of these, I have m and 7n, and so this would be m minus 7n, and m squared plus 7mn as you multiply these together, cube roots together, plus 49n squared as you square the second cube root. Moving on to number 21. Here, neither of these are perfect cubes, but we have a GCF of 4. So we get 4 factored out, and we get 1 minus 8h cubed. And we have 1 and 2h. So we have 4 out in front, 1 minus 2h in the first parenthesis, 1 squared, which is 1, plus 1 times 2h, which is 2h, plus 2h squared, which is 4h squared. We have another GCF here because 2 and 54 are not perfect cubes. But instead, we factor out 2 and we get x cubed minus 27y cubed. And we have x and 3y being our cube roots. So we get 2 out in front, x minus 3y in the first parenthesis, and x squared plus 3xy plus 9y squared for our second. Number 23, number 23, we start getting a different type of problem. These are now factoring trinomials. This is purely review. So trinomials, 3 terms, ax squared plus bx plus c. When we see this, we make the x. So we first make sure it's in standard form, follows this format, and then we make the x. And remember, when a is 1, we have a shortcut. When a is not 1, which we'll see on problems starting with number 31, we'll have to not use the shortcut. So I make the x here, which is a times c at the top, and b at the bottom. So I have 1 times 56 is 56, and 15 on the bottom. Remember that it's a, b, c for the coefficients of 1, 15, and 56. And now I find numbers that multiply the top, add to the bottom. And so it's going to be 7 and 8, or 8 and 7. The order doesn't matter, but the fact that they're both positive does, because positive 7 and positive 8 give you a positive 56 by multiplication and a positive 15 by adding. With the shortcut, since a was 1 here, we can just go to our factors and do the variable k, and then do plus 7 and plus 8 for our 2 factors. And whether plus 7 is in the first parenthesis or the second doesn't matter. Same is true for plus 8. And those are the factors. Same thing with number 24 here, so I'll make the x. A times c, or 1 times negative 30 is negative 30. On the b, we have 7. So 2 numbers that multiply to negative 30 add up to 7. It's going to be a negative and a positive in order to multiply to a negative. And the positive will be bigger because we're going to add to become a positive. And so we'll end up having the terms 10 and 3, with 3 being negative and 10 having to be positive to give us a positive 7 when we add. So our 2 factors are n minus 3 for one factor and n plus 10 for the other factor. And whether n plus 10 is first or second doesn't matter. Same thing for n minus 3. But it's what's on the inside that counts. It's a good life lesson as well. Number 25 here, we make the x again. There's no GCF to worry about. It is in the correct form or order. 1 times 64 is 64, and negative 16 goes on the bottom. So 2 numbers that multiply to 64 but add up to negative 16. That's going to be negative 8 and negative 8. So this becomes p minus 8 and p minus 8. And since those are the exact same, you could choose to rewrite this as p minus 8 quantity squared, which just means 2 of the same thing multiplying together. And either one, the orange or the green, is perfectly acceptable. On to number 26 here. Once again, no GCF, everything's in the right order, so we'll make the x. 1 times negative 42 is negative 42, and 1 times, or excuse me, negative 11 just goes on the bottom. So it will be a negative and a positive as they multiply to a negative, and the negative will be bigger because it adds up to a negative. And so as I'm thinking through, what numbers could possibly work here? Well, it'd be negative 14, positive 3. If at any point you're ever stuck trying to find the pairs here, write out factors of 42 as pairs. So for example, 1 times 42, 2 times 21, 3 times 14, 6 times 7. And you'll notice, oh, we found the pair right here that works. That would add up to negative 11 when the signs are opposites. So now we'll go ahead and write our factors, and this is r minus 14 and r plus 3. On to number 27. So we have a GCF here actually. We might notice that this is cubed. And when we factor that out, we get w squared plus w minus 20. And now we make the x with these new terms, where this is our a, our b, and our c. C is all of that, to be clear. And so 1 times negative 20 is negative 20, and the b is 1. And so you have to find two numbers that multiply the top while adding to the bottom, and this will end up being negative 4 and positive 5. And so our two factors for what this turns into are w minus 4 and w plus 5. And this w just remains out in front. Number 28 here, it's in the right order, but we do have a GCF this time. Our GCF is 2a. I'll be left with a squared plus 19a plus 34. We make the x here. 1 times 34 is 34, 19 on the bottom. And 17 and 2 do the trick, both positive. So a plus 17 is one factor, a plus 2 is the other, and there's a 2a out in front as the GCF still from up here. 29. There is no GCF between these three. Now notice this is the end of the fourth and n squared, so our shortcut will change just ever so slightly after we make the x, but making the x is still the same. So we have a times c, which is 1 times negative 24, and b is still 2, and we end up finding that negative 4 and positive 6 will do the trick. So now when we go to make our shortcut, we'll still have minus 4 and plus 6. However, since this is n to the fourth, n times n is not n to the fourth. It's n squared. However, n squared times n squared is n to the fourth, so we just take half whatever this exponent is. Just on every previous problem, half of the exponent of 2 was just 1. And then this can actually be factored further because that's a difference of 2 squares. We have to look for that when we have the opportunity. And so we say, oh, okay, that's n and 2. So it's n minus 2, n plus 2, and our other factor is n squared plus 6. And this would be our answer. Number 30, you have x to the fifth, x to the third, and x. Oop. The fact that the last term has a variable the same variable, I should say, as this is an indication we'll have a GCF since they all have matching variables this time. Now, if this were to be like a y, to the fourth, something like that, then it's not necessarily a GCF. So I'll factor out an x and get x to the fourth minus 24, x squared minus 25. Go ahead and make the x, and I get negative 25 on top, negative 24 on bottom, and I end up getting negative, multiplying 25, adding up to negative 24. That'd be negative 25 and positive 1. And so I end up having x squared minus 25, remember half of the exponent of 4, and the other parentheses x squared plus 1. The other thing is it also is going to match this exponent too, if that helps. And the x is out in front as a GCF still. Moving on to number 31. 31, we start getting to a point where we have to use something else other than the shortcut. We have to go the long way, unfortunately. So here we'll go ahead and make the x because there's no GCF, and 3 times 8 is 24. Remember, it is a times c at the top, and negative 10 is at the bottom. So finding two numbers that match this will end up being negative 4 and negative 6, multiplying to a positive 24, while adding up to a negative 10. And now what we end up doing is we rewrite this. We do what's called split and group. So the first one stays the same. Let me actually color code that differently. The last term stays the same. And the middle term splits into these two coefficients. So negative 4x, same variable as here. If it was xy, this would be xy. If it was x squared, it'd be x squared. And then minus 6x. Once again, matching this coefficient with this variable. That was a splitting. Now time to group. So it's the first two in a group, the last two in a group, and we look for GCFs of each group. So in this first parenthesis, the GCF is just x, and we're up to 3x minus 4. In the second parenthesis, the GCF is negative 2. I know it's negative because I don't want this to ever start negative for a parenthesis, meaning if it does, like it does here, then we factor out a negative number. And so I end up getting 3x minus 4. Now this matches perfectly, these two parentheses. And if they don't do that at this step, something has been done wrong. So since they do match, I'll have 3x minus 4. And I'll just put that as one factor or one parenthesis. And our other parenthesis will be the stuff that was outside the GCFs, the x and the minus 2. I'd call it that we're packaging up the leftovers. And these are the two factors. And if you wanted to check your work, you'd be more than welcome to by distributing 3x and 4 and then combining like terms. On to number 32 here. 8x squared minus 6x minus 5. So no GCFs in their order. Go ahead and make the x. A times c, 8 times negative 5 is negative 40. B is negative 6. Finding two numbers that multiply to negative 40, add up to positive 6. Be a negative and a positive, and it's a negative 10, positive 4. So we rewrite this one to split in groups. So the first stays the same, the last stays the same, but the middle splits into negative 10x plus 4x. So now we group. So that's a split and group. And the first two have a 2x in common. And we're up to the x minus 5. And the last two have just a positive 1 in common as all. So we have 4x minus 5. And that's what my first parenthesis should have been, is 4x minus 5, not just x minus 5. And it's very possible that your GCF is just a 1. They don't have anything else in common. We do have to write that out there for the next step. So 4x minus 5, the matching part of these, becomes 1 factor. And the other stuff is everything that was outside of what I call the leftovers, or the GCFs. And so you have 2x plus 1. And those would be our answers. Number 33 here, no GCF between these four terms, so we'll go ahead and make the x. 3 times negative 5 is negative 15. 14 here at the bottom. So that'd be negative 1, positive 14. Now remember, you could put 14 on the left as long as it's positive and 1 on the right as long as it's negative. I just always choose to put the negative first if I have a choice between the two. So split and group, the first stays the same, the last stays the same, and we split the middle. And this, since it has x squared, will be negative 1x squared, or just negative x squared, plus 14x squared. So it has to have the same variable and coefficients there, or same variable and exponents. And now we group. And if you did have these switched around, by the way, you'd end up getting the same answer at the end, but your parentheses might just be swapped around the order that they're in, but the insides would stay the same. And some of your in-between steps would just differ slightly. So here, the GCF of my first parenthesis is x squared, and I'm left with 3x squared minus 1. And the GCF of my next parenthesis is just a 1. Wait, I did something wrong here. Oh, I see what I did wrong. Silly Mr. Kossel. This should have been a 15x squared. And this should have been a plus 15. this will work much better. So our GCF is not 1 for that second parenthesis at all, but rather, I forgot the x squared now. There we go. But rather the GCF is 5. And now we'll get 3x squared minus 1, which I knew there was an error there because these didn't match, and they have to match. If they don't match, you're doing something wrong, and I caught that I did something wrong. So now I put those in one parenthesis. One factor is 3x squared minus 1, and the other factor will be the x squared and the plus 5. And that's my answer. Number 34, no GCF between these three terms, so I'll go ahead and make my x. And at the top is 12 times 2, which is 24. At the bottom is negative 11. And I end up getting negative 8, negative 3. And we end up getting 12m to the fourth minus 8m squared minus 3m squared plus 2 as I rewrite my first and last terms and split my middle term into 2. And I'll group the first two together, the last two together, taking this negative with the 3m squared. And now my GCF of my first two is 4m squared, and I get 3m squared minus 2. And my GCF of my other one is a negative 1. We don't want to start out negatives, we have to factor out a negative. And we get 3m squared minus 2. And now these match perfectly, which is a good sign. And so one factor is 3m squared minus 2. Our other factor is 4m squared minus 1. But however, we're not quite done. And the reason why is this can be factored further. It is a difference of two squares. You're subtracting, and they're both perfect squares. 2m times 2m is 4m squared, and 1 times 1 is 1. And so this 3m squared minus 2 just remains unchanged, and so we just rewrite it because we can't factor it any further. But we factor the other one into 2m minus 1 and 2m plus 1. Now let's talk about four terms. And four terms is actually just what we did right here. It's everything after the split. So it's just the grouping. So it just says use grouping, which is what we've already been doing. So it's basically like our last four problems, just without having to make the x and fill that out and splitting. So group the first two terms together and the last two terms together. So group first two, last two, factor out the GCF. So x squared and x plus 1, and minus 4 and x plus 1. And then factor the common binomial, which is the x plus 1, what's inside the parenthesis, two terms, binomial. And then everything else, x squared minus 4 being the other one. However, this actually factors further, so I suppose I should actually write that a little bit smaller, because x squared minus 4 is a difference of two squares. So x plus 1, x squared minus 4, and then this is x and 2. For x times x is x squared, and 2 times 2 is 4. So x plus 1 stays the same, but then x squared minus 4 factors into x minus 2 and x plus 2. And that'll be the end of that example. And so now we'll go ahead and complete these 6 examples. So 4 terms. First two, last two for groups. We have x squared, x minus 1 is left, plus 9 is our GCF, x minus 1 is left. Once again, these should be matching. So we have x minus 1 for one factor, x squared plus 9 for another factor, and you may be wondering, Mr. Kossel, these are perfect squares. Do we keep going? No, because it's a sum. If this was subtraction, we would keep going. However, we're done. 36, factor the first two, factor group the first two, group the last two, and start factoring GCFs. We have k squared, which leaves k plus 5, and we have minus 1, which leaves k plus 5. So those match, become one factor, and k squared minus 1 is our other factor, which is a difference of two squares, k times k and 1 times 1. So k plus 5 remains unchanged, and so we rewrite it. And k squared minus 1 becomes k minus 1 and k plus 1. And we're done. On number 37. First two, last two. First two have a v squared in common, and we're left with 4v minus 5. Last two have a minus 4 in common, and we're left with 4v minus 5. Those match, which is good. So 4v minus 5 becomes one factor. V squared minus 4 is another factor. And we can keep going because that's the difference of two squares. So we have v and 2. So 4v minus 5 remains the same. We factor this difference of two squares, which is v minus 2 and v plus 2. Now we move on to number 38. First two, last two, and we have 2x to the fourth as our GCF, which is x minus 9, and then positive 7 as our GCF here, which is x minus 9. Those matching is good, so x minus 9 is one factor, not a difference of two squares, because this is not squared. And then 2x to the fourth plus 7 is our other one, which we can't factor further either, because they're not perfect squares or cubes or anything like that. I should fix my 4 a little bit, though. That might be less bad. Number 39. Group the first two, group the last two. First two have a c cubed in common, which gives us c plus 9. Last two have a negative 1 in common, which gives us c plus 9. Those match, so c plus 9 becomes one factor, and c cubed minus 1 becomes the other factor. This is not a difference of two squares. However, it's a difference of two cubes. C cubed is c cubed, and 1 cubed is 1. So the first c plus 9 remains unchanged. And then now we factor this into a binomial and a trinomial following our rule, where c is our a, 1 is our b. And we have c minus 1, c squared, plus 1 times c, which is c, plus 1 squared, which is 1. And that would be our answer. On to number 40. First two and last two again for grouping. Just a g to the third, no coefficient other than 1. We get 2g minus 3. Here we have a GCF of 8, which gives us 2g minus 3. So then we have 2g minus 3 for one factor, and g cubed plus 8 for our other factor. And this is a sum of two cubes. So g is the cube root of g cubed, and 2 is the cube root of 8. So we have 2g minus 3 for one factor, and g plus 2, following the rule, and g squared minus 2g, g times 2, and then plus 2 squared, which is 4. And so those are all of our examples, but now we're going to go to a graphic organizer that may be helpful to recap what we've done today and all the different methods and things we learned. So, factoring guide. You always check for a GCF first no matter what. And then you determine whether it's 2 terms, 3 terms, or 4 terms and go from there. If it's 2 terms, you look for one of these 3 things. Difference of 2 squares, sum of 2 cubes, or difference of 2 cubes. If it's 3 terms, then it's a trinomial and you make your x. So I'll write here, make an x. And if it's 4 terms, you group. Now if a equals 1, we can use the shortcut. And if a is not equal to 1, greater than 1 specifically, then we will split and group. And let's have an example problem for each of these. So for a difference of 2 squares, our example problem could be x squared minus 9. This factors into x plus 3 and x minus 3. Because x times x is x squared, and 3 times 3 is 9. Next, sum of 2 cubes. Our practice problem is going to be x cubed plus 27, which x is the cube root of x cubed, and 3 is the cube root of 27. And so this results in x plus 3, x squared minus 3x plus 3 squared, which is 9. And it may be helpful to write down the rule here somewhere. So maybe I'll write it up here, that a cubed plus b cubed gives us a plus b, and then a squared minus ab plus b squared. I'll do the same thing for the difference of two squares. I don't have room up top, so I'll write it down here. That a squared minus b squared is a minus b, and a plus b, with the order not mattering for which parenthesis comes first. The difference of two cubes, I'll do the rule down here. A cubed minus b cubed is a minus b. A squared plus a times b plus b squared. And let's do a practice problem. We'll do x cubed minus 64. So this is x is the cube root of x cubed, and 4 is the cube root of 64. And so that gives me x minus 4. X squared plus 4 times x plus 4 squared, which is 16. Now let's do our trinomial. Once again, if a is equal to 1, you can use a shortcut and you make an x. So for an example, we can do x squared minus 6x plus 5. And so we make the x here. And so we have a times c, which is 5 at the top, and negative 6 on the bottom. And this would end up being negative 1. So, yep, negative 1 and negative 5 that multiplied to positive 5 while adding to negative 6. And so our shortcut is just the variable, or with the half of the exponent, which half of 2 is just 1, minus 1, and minus 5, the two sides of our x's. Of our x, I should say, singular. Now, if you have a trinomial where a is greater than 1, you get to split and group. You can still make the x. So such as 2x squared plus 15x minus 77. The x here would be negative 144, and you have to add up to positive 15. My apologies, that would be negative 154 and positive 15. That would end up being negative 7 and positive 22. And so we go ahead and split and group to where the 2x squared stays the same, the negative 77 stays the same, but the middle splits, and then negative 7x plus 22x. And then now we group. And so x is our GCF for our first parenthesis, giving us 2x minus 7. 11 is our GCF for our second parenthesis, giving us 2x minus 7. And those match, so we get 2x minus 7 as one factor, and x plus 11 as our other. And last but not least, 4 terms off the bat, you just group. So x cubed minus 2x squared plus 6x minus 12 is our example. Group the first two, group the last two. First two have a GCF of x squared, which gives us x minus 2. Last two have a GCF of 6, which gives us x minus 2. So we have x minus 2 as one factor, x squared plus 6 is our other. And that wraps up Algebra 2, Section 5.3.